All right, so let's talk about the warm and fuzzy mole. Not the one on my back. The that joke never ever gets old. I don't know why. All right. Let's see. I've taught for 15 years, 530, like 300 times. Everyone laughs. Yeah, that's exactly right. Anyway, moving on. Uh, this is the first class all day I've actually done anything. It's very weird. I made a promise to myself if over half my students showed up in a class, I would teach. Too late. Now, chemists have devised a means of keeping track of the amount of matter. It is, thank you. Involved in chemical reactions. The this method uses the gram formula mass, better known as the molar mass, or mole, M-O-L-E, for short. All right. A mole is a word that means a number. That's all you really need to know. For some reason, kids, they're like, oh man, I hate moles. I never got it. Well, mole literally just means a word that means a number. Can you think of your life a word that is not a number but means a number? First? Okay, that means first. Means one. Okay. 5 is a number. Oh, pi. Sorry. That's better. What number does that mean? 3.14. Are we okay with that? Google means a number. So does the word dozen. Yeah, it's a number with 100 zeros behind it. What does dozen mean? 12. It's not the word 12, but it's a word that means a number. Are you okay with that? So please don't overthink a mole. A mole is just a word that means a number, but the number's freaking big. So I want you to memorize that it is a big A number. Can you memorize that right now? And if you're like, man, I am too pure to memorize that. A does not stand for what you think it stands for. So a mole just means a really big number. Now, the reason we use a mole instead of this big number is so that we can do math with the numbers 1, 2, 3, 4, or numbers that are easy to comprehend instead of moles, which a mole is this number. Thank you. I was hoping. That's a mole. How many would rather write the 1 mole instead of writing that big A number? Raise your hands. Okay. So please do not overthink a mole. Don't ever say, man, I hate moles. It's like saying I hate a dozen. Like, what did a dozen do to you? Usually that's good. It means donuts or cookies, right? A mole, maybe you hate it because it means chemistry, math. I don't know. All right, now, the reason we call this a big A number is because this number was discovered by a guy named Avogadro. And yeah, fine, it sounds like avocado. I don't care. And avocado and his guacamole. This smoke kid giving me crap. You're like around 300 times. Usually I get a slightly more positive result. All right, so you've actually heard of the name Avogadro. Did you know that? It was in the Atom Lab book. It was all the scientists. It wasn't one you had to memorize, but it was in there. that Avogadro, bless you, was able to determine the number of actual atoms in substances, and we call it a mole. Okay, big number. That's all you need to worry about. All right. In each element box on the periodic table, there are 2 numbers. So you need your periodic table out from now on. And you'll open to the middle where there's all sorts of numbers in it. All right. So here we go. In each element box on the periodic table are 2 numbers. The molar mass of an element is the larger of these 2 numbers. All right, for example, the molar mass of carbon. So if we find carbon, everyone find it. It's on the top right-ish. It has a C, it has a 12, and it has a 6. Now yours might have a 6 and a 12. The location doesn't matter. What matters is which one's bigger and which one's smaller. Okay? Tell your lab partner which number's bigger. Easiest question of the year so far, right? All right. So this number is called the molar mass. And if we were to write it down, please look, we would say that carbon has a molar mass of 12 grams per 1 mole. What that means is if we had 6.02 times 10 to the 23rd atoms of carbon, which instead of saying that, we call it a what? Starts with an M, a mole. If we had a mole of carbon, it would weigh 12 grams. All of those numbers are telling you the mass of 1 mole of the substance. Now, if you'll look, please, right here. From now on, I never write it this way because I'm lazy. So if you just get used to me doing it this way, then you'll know that that's what I'm doing. You okay with that? It just saves me from lifting my finger up. All right, 12 grams per 1 mole. Not hard. It's always the bigger of the 2 values. So now back to the notes. All right, so we would put 12. And then, here you go. It asks you to do these 6 on your own. Will you please do those 6 in the next 2 or 3 minutes that we started yesterday? Remember the weird math plus sign thing I made you do? All right. So the unit, grams per mole. If you find cobalt, it is rounded off at 59 grams per mole. Chromium, Cr is, where is it? There it is, 52, right? Grams per 1 mole. You all right with that? Then come over here, Kr. It's on the far right. That is 84 grams per 1 mole. Who thinks that's easy enough? All right, now remember, we learned this yesterday. If we have a ratio of 2 things, it could certainly be 1 mole per 84 grams. We can flip it to answer problems whichever way we need. Are we okay with that? All right, now, that's how you do this for just an atom. But it gets a little bit more complicated, but nothing's too, it's not our. There we go. Now, to find out what the mass of a molecule is, have I skipped anything? Okay. So a molecule means more than one thing together now. You must first count up the different types and numbers. Of atoms. So we're going to still look at the periodic table, but we're going to have to find what we have and how many we have of each. Easy enough. So look up here for a second, and then you can do them on your own. We have CuSO4. In this formula, how many copper atoms are there? False. Well, actually, maybe, I don't know what you said. There's 1. Maybe, I don't know. I thought I heard 4. This 4 only goes to the thing it's right next to. All right, so there's 1 Cu. How many S's are there? 1. Then how many O's are there? 4. Now, please let me help you with this one down here. Look at number 4. Can everyone see it? Well, you have it right in front of you. How many calciums are there? No. There's only 1 Ca. This 3 right here only belongs to the O. Are you okay with that? But please, the parentheses, though, means there are 2 of everything in there. So really, how many N's are there? 2 N's and 6 oxygens. Okay? We multiply, just like we would in math, we take the little subscript and we multiply everything inside of the parentheses by it. Try the next, or try those 2. So we have 6 carbons, 12 hydrogens, 6 oxygens. Anyone know what this is called? Should look familiar. That's sugar, or glucose. All right, aluminum chloride, that would have 1 Al, 3 Cls, and this was easy, just 2 H's. Piece of cake, right? Uh-oh, what did I do wrong? What did you do wrong? Because there's nothing that's just I. So Al is one symbol, aluminum. Is that your question? Okay, so it's aluminum, and it's not capitalized, but we'll pretend it is. And chlorine, and it is tricky because there are I is a thing, all right, and then it's that. So it's 1 aluminum bonded to 3 chlorines. But the lowercase l, I will agree, in chemistry is a problem occasionally. All right, that was a good question. Okay, next thing, here we go. Next, we will multiply the number of each type of atom by the molar mass of that element. So now we'll use the periodic table again. So in copper 2 sulfate, we said there was 1 copper, 1 sulfate, there are 4 oxygens. So now we go 1, that's for the copper, and we find its molar mass. Copper is what? 63.5. Does everyone know where that number came from? From your periodic table. Got it? All right. Then we're now to sulfur. This is representing sulfur, and its molar mass is 32 grams per mole. And then tell your lab partner right now. Tell them, where did that 4 come from? Ready, set, 10 seconds. 9. Thomas, you know where that 4 came from? Right here, correct? That 4 came from here. And now we find oxygen. There's 2 numbers for O. There's 16 and there's 8. So it's the bigger of the 2. Then we're ready. We take this plus that, and then we add 4 times 16, which is 64. You'll need a calculator. You can use your phones. I have that box back there with calculators in it. Will you all add that up? All right, so we add that up. We get 159.5. I'll take a couple minutes and do this by yourself. Did you win?
No, I took third.
Okay, everyone right here. Let's do this one together, since that's the most complicated one. So how many CAs are there? Sorry. I'm going to do it right here. There's 1 CA, and I'm going to multiply it by 40. Now, you don't really have to do that part, but I'm just doing it to go through the process. Are we okay with that? If it's just 1, whatever. All right, how many N's did we say we had? We have 2 N's, and their mass is 14 each. And then, how many oxygens did we say we had? We had 6 of them. And I'm going to multiply that by 16. And I add that together. And I don't remember. What was this? 164? 164 grams per mole. Who had that? Okay, we're literally trying to baby step through this so that it's not that hard. Okay, good, I am recording. All right, the next part we're going to do is we're going to use these numbers in the picket fence thing we learned yesterday to solve very, very simple chemistry-related story problems. So here we go. Now you know how to construct a proportion. Oh. Okay, somewhere. So we have proportion right here for the molar mass of a substance. So molar mass is grams per 1 mole. Every single time it's grams per 1 mole. Now it could be 1 mole per grams, right? We can flip it over if we need to solve a problem. Now we can use this proportion with the picket fence. That's pretty easy to read for the internet viewers. The picket fence. To calculate the number of moles or the number of grams in a quantity of a substance. All right, it's extremely simple if you'll just set it up the way I want you to set it up every time. At first, it might seem weird or hard or tedious, but it's worth it, I promise. So, I'm going to ignore this just for a second, and I know you have it, but whatever. It says how many moles are in 26 grams of H2? So let's remember, to make a picket fence, we just put a little plus sign, right? And we start where with what? All right, top left with the loner, and there's only one number given, right? So I'm going to start with that. 26 grams, and I'm going to put H2. You okay with that? Now this problem you could do in your head in 10 seconds. It's 13. It's not hard, but we're doing this while it's easy so that when it's hard it isn't. So now we're going to use this. The formula is what I refer to as the hidden proportion, because there's no other number given here, but if I find the molar mass of hydrogen, it's a number. It was 2 grams per 1 mole, correct? All right, now the picket fence says the unit here goes where? Remember? All right, bottom right. So these units right here will always match. So on the bottom, I hate when that happens. I'm going to put the grams, and then my answer was mole, so I know the top has to be mole. And my proportion said I had 2 grams for every 1 mole. So I take 26 times 1 and divide it by 2. That's not hard. That's just 13, right? And look, I know you could have done that in your head, but you can't do most of these in your head from now on. Okay. Now, in this problem, we solved for moles. We can use the same process to solve for grams. And I'm going to ignore this part again. Let's draw a square over it. How about that? If that'll work. That's perfect. Okay. I'm going to use the same process. I'm going to put a plus sign. What number did I give you? All right, 2.1 moles. AlCl3. And automatically that means what unit goes here? The same one, right? Moles. AlCl3. The problem's asking me for grams. What do you remember about the unit at the end? All right, it's the same as the top one. So now I just need to find the molar mass of AlCl3, which I already did, right? That's the 133, isn't it? 0.5. And is it not? It is. It is. It's just on where you did it before. Look at the top of the page, maybe. Okay, so I take this proportion, and now it stays the same way. And I have 1 on the bottom. So I take 2.1, and I multiply it by 133.5. And I get, is that 280 or something like that? What was that one? 280.4. Okay. There are more. All right. Let's do number 3 real fast, and then I'll let you go. Number 3, if you look at me, sugar, I just have it memorized. Sugar's mass is 180 grams per 1 mole. Now, you had already calculated that anyway, hadn't you? All right. The rest of it, well, you've done 4 also. The other ones you have not, but you can do them. All right. So I'm going to put my picket fence. I take the number and unit it gave me, 107 grams, and I'm lazy, so I'm just going to write sugar, S-U-G, because C6H12O6 is kind of a pain in the butt. Okay, so look, that means what unit goes down and over? All right, grams of sugar, and I have this proportion that there are 180 grams of them for every what? 1 mole. Does it want me to answer in moles? Yes, so I'm ready to go. 107 divided by 180. 0.56. Got that one? 0.59. Now, just as a side note so you don't panic, typically, if your answer's moles, it's a smaller number. If it's grams, it can be a very big number. One of these answers coming up is really big, and kids are like, oh, I did it wrong. You can get really, really big numbers. Okay? So moles are usually small. Grams are usually big. Will you do the next 3 when you're done? Compare them with your lab partner, and if you have problems, see if you can figure it out together.